Hey guys. Alright, today we are going to talk about constant rate of change. Your objective for today, I will be able to represent constant rates of change in mathematical and real-world problems. Alright, so first of all, what is a rate of change? Well, a rate of change is a rate that describes how one quantity changes in relation to another. Now, if the rate of change between any two quantities is the same, they have a constant rate of change. So when you think of how one quantity changes in relation to another, I want you to think about the graphs that we have been creating in the past week. As x changes, y is also changing. Now, whenever they change at a constant rate, you are going to get a linear graph. And remember, linear means it forms a straight line. So, constant rate of change can be seen in this image right here. Now, if we look in the middle here, this rate of change is not constant. And the way we know that is because this graph curves. And it has to be a straight line to be constant. Over here on the last one, it makes a straight line, but it is completely horizontal. So that means that there is no rate of change. Now, the reason that happens, let's say that this value is 5. Let's say that y equals 5 right here. So as x is increasing along this line, y stays the same. So right here, y is not changing. And in a constant rate of change, it's how one quantity changes in relation to another. So both x and y have to be changing, and it has to create a linear graph like we see here. Alright, so let's talk about how to find the rate of change. Well, step 1, we want to find the pattern of change in the dependent variable. Remember, dependent is y. Step 2, we want to find the pattern of change in the independent variable. Remember, independent means x. And then step 3, we will divide. And then in simpler terms, rate of change in y divided by the change in x. So let's look at this example. So example 1, it says a computer program charges customers per line of code written. Fill in the blanks with the amount of change between consecutive numbers. Well, before I find the change, I want to identify which of my variables is x and which is y. So I have lines of code, and then I have the cost. Remember, think about independent and dependent variables. Think about what has to happen first. Okay, independent happens first, and then dependent happens after that. That's like the effect. Alright, so we have lines of code and the cost. You have to actually write the lines of code, then determine how much it will cost. So since this happens first, it's independent, that's x. The cost would be dependent, and it would be y. And if you think about it, the cost depends on the lines of code. Now we're going to find our change in y. So what I want you to do is look at your y values. We are going from 1,000 to 2,000. I want you to think about what amount of numbers is in between that. So think of the difference. If we're going from 1,000 to 2,000, we have 1,000 in between that. If we go from 2,000 to 3,000, we have 1,000 in between that. And specifically, we are increasing by 1,000. Now if we go from 3,000 to 4,000, we are again increasing by 1,000. So our change in y would be 1,000. Now let's talk about the change in x. So we're going from 50 to 100. So we're going up 50. Then we go from 100 to 150. We're going up 50 again. And then 150 to 200. So we are going up 50. So that means that our change in x is 50. Now we have 1,000 divided by 50, so let's go ahead and work that out. And I am going to write that up here. Remember, top dog goes in the house. 50 cannot go into 1, it cannot go into 10, but it can go into 100 2 times. So I subtract, get a remainder of 0. I bring down that last 0. 50 goes into 0 0 times. So that means that my constant rate of change is 20. All right, example 2. What is the constant rate of change between the quantities in the table? So we have dogs and we have legs. So again, let's determine which is X and which is Y. Okay, we have dogs and we know that dogs have 4 legs, okay? So the number of dogs is going to affect how many legs there are in total. So our dogs would be independent and then the legs would be Y. The number of legs depends on the number of dogs. All right, so now that we know that, let's find the change in Y. So let's look at Y. If we are going from 8 to 20, we have gone up 12. If we are going from 20 to 28, we're going up 8. And if we go from 28 to 40, we're going up 12. Now, if you notice in the last problem, we got the exact same numbers in all the boxes. Now we do not have the same numbers. And I'm going to show you what we're going to do with that in a moment. So let's look at X. Let's find our change in X. When we go from 2 to 5, we're going up 3. 5 to 7, we're going up 2. And then 7 to 10, we are going up 3. So again, last problem we had X changes in X that were all the same. These are different. So here's what you're going to do in a situation like that. You're still going to take your change in Y and divide by your change in X, but you're going to have to do that for each one. So this is a set, this is a set, and this is a set. So I'm going to take 12 divided by 3, which we know equals 4. I'm going to take 8 divided by 2. That also equals 4. And then 12 divided by 3 would just again be 4. So as you can see, they both have the same constant rate of change. So since whenever the change in Y divided by the change in X, if it always equals 4, that means there is a constant rate of change because you're getting that same number each time you divide. So 4 would be your final answer. Okay, now we want to use the table to find the constant rate of change, but we have an empty table. Well, if you look here, we have a graph, we have time, and we have distance. So distance is our Y value. That means it's dependent. So Y is going to be our distance in miles. Time is on the x-axis. So our time in hours, that's going to be the x value. Now we're just going to look at these points, and we are going to record those on this table. So the very first point that we see, we have x at 2, y at 80. So we have 2 and 80. Then we have x at 4 and y at 160. Then we have x at 6 and y at 240. All right, now let's find the change in y. If we are going from 80 to 160, we're going up 80. If we're going from 160 to 240, we are also going up 80. Now let's look at y, or at x, I'm sorry, let's look at x. If we're going from 2 to 4, we're going up 2. If we're going from 4 to 6, we are going up 2. So in this problem, we have the same change in y, and we have the same change in x. So I'm just going to take a change in y, which would be 80, divide it by the change in x, which is 2. And we know 80 divided by 2 is 40. And I apologize, it's a little scribbly. All right, so our constant rate of change in the situation would be 40. All right, now it's time for you to try this on your own. Make sure you complete this and have this as part of your notes to bring back to class. Make sure you have written down everything you see and everything that I wrote down. Have a wonderful day, and I will see you in class.